Hi, my name is Karin Cooke and I'm a first-year PhD student working at Moucons Talence near Bordeaux and also Géosciences Montpellier in France. And I would like to present my poster with the title On the Potential of Vertical Gravity Gradient Monitoring for Hydrological Signal Detection. And the background of this is that gravimetry has been increasingly used in hydrogeological studies. And what I would like to also look at is how can we increase the spatial localization of mass changes. So as you might know, that gravimetry has the disadvantage that you have the non-uniqueness of the solutions. But if you look at the combination of the vertical gradient and the gravity signal itself, you might get a better idea where to find your mass changes and how they change in time and space. So for this particular study, I monitored the vertical gravity gradient in a study site in southern France. That's the Geodetic Observatory in the karstic environment on the Larzac Plateau, about 1 hour drive from Montpellier. And what I did, I measured the gravity with a movable relative gravimeter, the Scientrex Autograph CG5. And as you can see in this diagram here, this is basically the observatory building. It's a really small building of 7 × 8 meters. And there you have concrete pillars that are used for gravimeter operation. And I measured gravity, which is relative gravimeter, on 3 different heights. And I moved around on 3 different concrete pillars. So as you can see in this diagram over here, I moved the gravimeter on the tripod. And I went up in height and went down and I moved around the pillars and I did this 3 times. And I did this survey for more than half a year. After all the corrections and the post-processing, as removing the solid tides and the ocean tides and all the details, I don't want to talk about it right now, but let's zoom into the results. And here you can see the more or less monthly monitoring I've conducted. And you see temporal and spatial variations. And how could we explain them? Let's look at the spatial differences. Well, I don't want to talk about it too much, but it can basically easily be shown with forward modeling that we can explain the spatial differences between the pillars just by making a forward modeling of the concrete pillars, because we know the size, the density, and the geometry and the structure of the observatory, and that is how we can simulate the change in gravity, so the gradient and also a little bit the curvature, just by knowing the size and the structure. And as you can see here, it matches quite well the simulation and the observation. But yeah, so that's the spatial differences that can easily be explained. But let's look at the temporal variations. How can we explain them? So for this really remote observatory in a calm environment, we only expect hydrological mass changes to be responsible for these mass changes. And if you look again at the data, so I did this more or less monthly observations. And then, as you can see, the lump data over here, that is where I wanted to check the repeatability of this measurement. And I've been in the field for a couple of days in a row. And here I wanted to zoom in. Here I had 3 days of remarkably similar weather conditions. And in this plot, I would like to show that here you see the change in vertical gradient for these few days in comparison with the difference between one survey and the other. And the repeatability of these measurements were about, around 5 earthworths. On the other hand, from, for example, April to May, I saw differences of, up to 80 earthworths. So that makes it more likely that what I see here could be signal. So my monthly variations are higher than the noise level. So what I'm going to do with this now? Now it would be interesting to zoom into the hydrological data that has also been collected at the site, and then start a correlation and see how do rainfall data and borehole data match up with these observations. Is there a link? And the other thing is also to do forward modeling and see if I construct a hydrological model around my observatory building and do an infiltration simulation, do my simulated gravity and gradient responses on the pillars, do they match up with what I measure in the field? So my idea is to have a coupled development of simulation and observation and see whether this simple study of a vertical gradient monitoring scheme could be used to better understand soil moisture changes. So do we actually detect the water infiltrating in the soil with these studies? We will see. Thank you.